Yeah, I welcome you again to this lesson, members. And we are going to look at our final part. Today, even I decided that we do pure math, then the day of pure math, we shall do applied. Okay, so I want us to complete integration in this lesson. And the last part that we are left with to complete integration is the splitting of the numerator. Splitting of the numerator. Okay, so when we are looking at the splitting of the numerator, we are going to look at how this splitting of the numerator is done, and on what conditions do you split the numerator. Okay. On which conditions do you split the numerator, and very many other aspects. So now, when in a case where we have got two cases, but we are going to begin with a case where, let me say case one. And for this case one, we are going to have a fractional integrand. If you have a fractional integrand expressed in this form, f of x, you have a form f of x out of g of x. If you have this form of an integrand, okay, and it's such that this g of x, or the denominator, cannot be factorized, or you cannot easily write it in partial fractions. If you find that the denominator cannot be passed cannot be expressed in partial fractions, or if you cannot factorize it very well, okay, then it is normally essential and very useful to express it as fractions by splitting the numerator. But there are two cases whereby you have the case of algebraic functions, and we shall also have a case where we are entirely dealing with the trigonometric functions. So those two cases are going to bring us to an end, or to the end of this topic called integration. Now, split the numerator, what we do, we use the condition that the numerator is equals to a times the derivative of the denominator, then plus a b. That is the condition that we use. Numerator is equals to a times the derivative of the denominator, then plus b. That is the condition that we shall use. Now, given this condition, we can be able to integrate the cases of integrals that are taking this form, but the denominator cannot be factorized. Now, as I told you, since we've looked at variety, since we've looked at a lot of integrals, now it becomes a bit easy. It becomes a bit easy for you to integrate some functions, because you'll be integrating some function, and along the way, you meet a case where you have to express it as a partial fraction. You meet a case where you have to use or apply the sign substitution. You meet a case where you have to substitute tan substitution. So that way, you can easily integrate most of these functions. You can meet a case where you have to first complete a square for you to go ahead. So let's look at examples, and there we can move. So let's look at examples. I will do like 3 or 2, then you do the rest, okay? Examples, it's a matter of knowing the concept. Find the following integrals Find the following integrals. A 2x minus 1 x squared plus 3 dx. B 3x plus 4 9x squared plus 6x plus 5 dx. C integral of x plus 2 x squared plus 2x plus 4 dx. D, you have an integral of 2x plus 3 over x squared plus 2x plus 10 dx. Then E, you have x over x squared plus 3x plus 5 dx. Then G, for G, I think those are enough. Maybe others I'll bring them in as an exercise. I'll just do like 2 of these. Then I let you be 2x over the root of 9 minus x plus 2 squared dx. So we are having these integrals, and you're going to do what we can to solve some, and then you practice the rest. So it's a matter of inspecting, and you really see that the denominator cannot easily be factorized. And if the denominator cannot be easily factorized, then it means that you cannot use these substitutions that we've been looking at, but instead use the splitting of the numerator. Let's see how it is done. So members, before I start on how it is wired in, I want to let you know that integration has got a lot of cases which you've tried to cover. So it's a matter of revisiting your work as much as you can. Ensure that you're doing the right thing out there. Okay, let's see. Solution. If you look at that part A, where we have the integral of 2x minus 1 over 4x squared plus 3 dx. Looking at this integral, we need to first get the numerator. Remember, we said that the numerator is equals to A times derivative of B, derivative of denominator, then plus B. So this condition you need to come with it. So it's going to be A into the derivative d dx of the denominator, and the denominator is 4x squared plus 3, then plus B. So the numerator, you have it, of course. The numerator is 2x minus 1. So 2x minus 1 is equals to A times the derivative of the denominator. Now, when you differentiate this, you'll get 8x plus 3, then plus B. And we are going to do what we can to solve for the value of A and B. We're going to do what we can to solve for the value of A and B.
Is it just 8x?
I beg your pardon?
Is it not just 8x?
But that's what I've written. When you differentiate 4x squared, you get 8x.
Yes.
And that is what I've got.
So how about
The 3.
3.
Oh, sorry. You're watching. Sorry. Okay, that's good. That's good. Sorry. So we get to x minus 1 is equals to 8x plus b. Good. That's very good of you guys. Now this one will be, let me rewrite it well. 2x minus 1 is equals to 8ax plus b. Here you can equate the coefficients of x. If you equate the coefficients of x, this side you have 8a and this side you have 2. Okay, so equate coefficients of x, or someone can set x as 0 to get b, so whatever. So let me equate coefficients of x. This side we have 2 and this side we have 8a, implying that my a is a quarter. Good. Then for the case of b, we are going to equate the constants. So if you equate constants, this side the constant is -1 and this side the constant is b. It doesn't have any x, so meaning that b is equals to -1. Now you've gotten a, you've gotten b. Now you're going to come and say that the integral of 2x minus 1 over 4x squared plus 3 dx is going to be equal to, remember you have 2x minus 1 is equals to 8ax plus b. But remember all this one, you just equated it to the numerator, but still you have the denominator for x squared, so you don't need to neglect this. So where a is, we shall be putting a quarter. Okay, so it is going to be the integral, we just substitute. So it will be the integral of a, which is a quarter, times 8x, because a is a quarter. So a quarter 8x, all right? A quarter 8x. Then out of the denominator, you have to bring it again, 4x squared plus 3 dx. Then plus the value of b, which is -1. So we shall say integral of -1 out of 4x squared plus 3 dx. That is what we are having. And as easy as usual, you cannot fail, or we cannot fail to integrate such functions. So let's see. Let's see how best we can do that. Well, what you do, you have to factorize out a quarter for you to easily integrate this. We can factorize out a quarter integral of 8x over 4x squared plus 3 dx plus, you can say -1, so minus integral of 1 over 4x squared plus 3 dx. Interesting. So this is the same as, of course, when you look at this, when you differentiate the denominator, you get the numerator. So this is going to be a quarter ln 4x squared plus 3. In cases where you find when you differentiate the denominator, you get the numerator, we employ ln. Minus, now for the case of this, you're going to put tan substitution, okay? You are going to put tan substitution. So it will be integral of 1 over this one, let me say 3 plus 4x squared. dx. How many of you can integrate this according to the tutorials we've had? How many of you can integrate this? Because if you don't want to make a mistake, because one may not easily verify it from here, but someone who is technical can see that you will have 2 over root 3. But if one finds it hard for them to work on, then you can integrate it separately. So for integral of 1 over 3 plus 4x squared dx, all right, for this integral, this one is going to be the integral of 1 over, you first factorize out a 3, so it is going to be 3 into 1 plus 4x squared out of what? Out of 3, then dx, which is going to be, you can move out a third outside, so it is going to be a third integral of 1 over it is 1 over 1 plus this one. We can put it under the fact that we want to square it at once. So we are going to say 2x out of what? Out of root 3, then squared. Then for this case, we shall let 2x out of root 3 to be equaling maybe to tan theta, so that our theta becomes the tan inverse of 2x over root 3. When you differentiate both sides, you get 2 over 3, 2 over root 3, sorry, dx is equals to, when you differentiate tan, you get x squared theta d theta, implying that your dx, of course this is dx, your dx is going to be equal to root 3 over 2 x squared theta d theta. Then you bring all this into here. So it is going to be a third integral of 1 over 1 plus this one, all of it was tan theta. So when you square it, it was going to be tan squared theta times dx, but dx is root 3 out of 2 sec squared theta d theta. Sec squared theta will cancel with 1 plus tan squared theta. So that you get, let me first capture this. So that you get, we have a third. Now it is going to be a third integral of root 3 out of 2 d theta. So you can move these constants outside so that you get root 3 out of 6 integral of d theta, which is going to be root 3 out of 6 theta. Then we know what our theta is equal to. So this is root 3 out of 6. Theta was tan inverse of 2x over root 3, 2x over root 3. Then you are going to bring this one here to the case where we have to move it at once. So it implies that the integral of 2x minus 1 over 4x squared plus 3 dx is going to be equal to, a quarter ln, we had a quarter ln 4x squared plus 3, then minus the integral of this one, which is root 3 over 6 tan inverse 2x over root 3, then plus a constant of integration. That is what we are having. That is what we are having. Okay. Okay. If you're with me, type yes and I see. If you're really with me, type a yes so that I see. It's a matter of the moment you get the first steps of how we calculate, those first steps, tan substitution, sine substitution, the rest of the things are the same. Okay, the rest of the things are the same. Okay, so now that is what we have, or that is what we get. From this example, we are going to do another example. You will always love that you just see, you follow, and then you can calculate them on your own and see how best you are capturing the work. Okay, you can try calculating it on your own and see, me as person W, can I get it without looking at what the teacher was doing? If the answer is yes, then you will be a hero to yourself and to the subject. So after having done that question, let's do question 2. What I want you to practice much, I just really want you to practice how to complete the squares of most of the expressions, completing squares, because we won't survive in some cases. Okay, now let's do this. We've got an integral of 3x plus 4 over 9x squared plus 6x plus 5 dx. That is what we are having. 3x plus 4 over 9x squared plus 6x plus a 5. Still, this one cannot be factorized. If you want to know that the function maybe is not factorized, try putting it on a calculator and see if you get direct values. If you can't, then it means do otherwise. Now, we have it that the numerator is equals to a times derivative of denominator plus what? Plus b. So the numerator is 3x plus 4 is equals to a times derivative of the denominator. You differentiate the denominator, 18x plus 6, then plus b. So you can expand this and you have 3x plus 4 is equals to 18ax plus 6a, then plus b. This is 3x plus 4 here. So you can equate coefficients. Equate coefficients of x. If you equate coefficient of x here, we shall have a 3 is equals to 18a. So what is my a members? 1/6. Then for constants, we have a 4 this side is equals to this side is 6a plus b. But you already have an a, as a sixth. So we shall say 4 is equals to 6 times 1/6 plus b, and you're going to get your b as 3, because this one will be 1, you subtract it from 4, you get b as 3, implying that the integral of 3x plus 4 out of 9x squared plus 6x plus 5 dx, all right? Dx is equals to the value of a. The value of a, this is, the whole of this is a stuff. So this is 18, but the value of a is a 6th, so it is going to be the integral of 1/6 of 18x plus 6. No, plus 6a. Okay, 6a, remember, 6a is, we are going to have 18ax plus 6a, then plus b. So it's going to be 1/6, 18x plus 6, is it plus 6? Over 9x squared plus 6x plus 5 dx, then plus the value of b. Yes, Emily?
So it's supposed to be 18x plus 1.
Oh yeah. 18x plus 1, good. Then over this, then plus the value of b, which is it?
I think the value of b is 4.
The value of b is 3. So it is 3 over 9 x squared plus 6x plus 5x dx. Okay. What does this mean? What does this one mean? Members, let's do this for the case of a here. Since here we have 18ax, I want you to look at it like this. We have 18ax plus 6a, meaning that someone can have a into 18x plus 6, and since we have a as a 6th, let's have it as a 6th of 18x plus 6. Okay, let's have it as a 6th of 18x plus 6. Do you get my point here?
Yes, sir.
Yes.
Let's take it like this, because I'm interested in if the derivative of this be equal to that, and indeed yes. So if you factorize it out total as 1 here, it's going to give you very much hard time. Okay, so here you can easily move out 1/6. You can easily move out the 1/6, so it is going to be 1/6. Okay, it's going to be 1/6 integral of what? Of 18x plus 6 over 9x squared plus 6x plus 5 dx. Nagato, what is it? Then plus, here you can move out 3, integral of 1 over 9x squared plus 6x plus 5 dx. If you're with me at this point, first type yes and I say, I don't want to leave you here. I don't want to leave anyone before things come in hot. I don't want to leave anyone. So if you're with me, type yes here. That's good from some people. Now, after getting these members, after getting this, this is going to be 1/6, and you can really see that when you differentiate the denominator, you get the numerator. I guess everyone is observing that. When you differentiate the denominator, you get the numerator. So meaning here we shall say ln of 9x squared plus 6x plus 5. Then plus, here it is not the case, meaning you have to apply some other thing. And what thing is that? It is going to be 3. Yes, Emily?
Teacher, why do we make it lean?
Emily, you scooped in late. Most of the things we covered them previously. I'll give you the links, you follow those videos. But the moment the derivative of the denominator is the numerator, then the once differentiated, rather once integrated, this one has to merge as lean. We looked at integration of lean of trigonometric, rather of logarithmic functions. Maybe that video will help you much, but because it is a longer process, that's why I'm saying that when you differentiate the denominator and you get the numerator, then the integral is taken to be lean of the denominator. I will send you the link so that you cover all you did not attend to. Okay, so plus 3. Now here it may be, I may need to express this, or I may need to complete a square on this, because there is no way how you can work on this thing without completing a square. Okay, so I will say 3, let me first factorize out a 9, so that it becomes 3/9 integral of 1/, if you factorize out a 9, what has remained? I'll be remaining with x squared plus 6x/9, okay, plus 6x/9, then plus 5/9 dx. Now, since we already have this, so now let's first work on this. Let's first work on this only, okay? So I'm going to say for the integral of 1/x squared plus 6/9x plus 5/9 dx, this is going to be equal to, I'm guessing that all of us can complete a square from, because we've had a lot of questions that we complete a square. So can I assume that all of us can complete a square? Can I assume that we can complete a square, all of us? Someone is saying, yeah, you assume, but others are quiet. Anyway, when we are completing a square, we say that you write x squared plus 6x/9, leave space, which space you will add something. Now, then you add 5/9 plus 5/9. Then on this space, you put half coefficient of x, then squared. A half times coefficient of x. Coefficient of x is 6/9. Then you square. So this is 6/18. All right? 6/18. 6/18. 18 squared. But 6 over 18 can be reduced inside to 3 out of 9 squared. So on this space, you will put 3 out of 9 then squared. But because we don't want to change the meaning of the initial function, x squared plus 6x plus 5 over 9, we shall subtract what we have included, which is 9 out of 81. So 9 out of 81. So the moment, now these ones of the squares, we shall have x plus 3 out of 9 squared. Then for this case, what remains here is 5 over 9 minus 9 over 81. 945 over 81. What is 45 over 81? What do you get? When you get 5 over 9, your calculators can bring it out well. When you get 5 over 9 minus 9 over 81, which fraction do you get? Do you get 4 over 9? Yes?
Yes.
So we shall have plus 4 out of 9. So that is what you'll put here. So it is x plus 3 out of 9 squared, then plus 4 out of 9 dx. Now, here you can see that really we shall employ tan substitution because it is taking the form that necessitates us to apply tan substitution. So let me first capture this, then we do progress. Interestingly, we are going to have, I'm going to move with this. I'm having the integral of 1 over x plus 3 over 9, then plus 4 over 9 dx. Now, someone can work on this function by beginning with this, because we have to factorize, of course, to make sure that here is a 1. So we shall have integral 1 over 4 over 9 plus x plus 3 over 9. Most of these steps can be skipped if you are cautious, but to avoid making mistakes, you can follow all your steps. Now, this one here, we can factorize out. Okay, we are going to factorize out 4 over 9. And when you factorize out 4 over 9, okay, it is going to be equal to 1 over, factorize out 4 over 9 here. So you'll be having 1 left, okay, plus this one here, then divided by 4 over 9, because you have moved it out, so you have to divide it everywhere. So when you divide it here, you get 1, and when you divide it here, you get 9 over 4 instead. So we shall have 9 over 4 over x plus you'll have x plus 3 out of 9, everything squared, then dx. Factorizing, whatever you factorize out, you have to divide it to get what remains. So if you factorize out 4 over 9, you will get remain with 1. But here also, when you divide by 4 over 9, it will be as if you have multiplied a reciprocal 9 over 4. Then now, still, we are going to factorize out this 4 over 9. And when we are factorizing it out, of course, it will be like 1 over 4 over 9. So we shall put out 9 over 4 integral of 1 over. Now we have to ensure that this one has appeared as a square, all of this. So it is going to be 1 plus, for this one to appear as a square, we shall have 3 over 2 into x plus 3 over 9, then everything squared, then dx. All right. So now we can let this one, which is under the square, all of it to be tan theta. So let 3 over 2 x plus 3 over 9 be equal to the tan of theta. Now, if you let it to be tan theta, and when you multiply, then when you differentiate, you'll get 3 over 2 dx is equals to sec squared theta d theta. Why am I doing this? Because when you multiply this one by x, it will be 3 over 2x, then this one will be a constant. So when you differentiate this, you get 3 over 2, but when you differentiate a constant, you get 0. So that's why I'm having only 3 over 2 dx, implying that your dx will be, of course, you cross multiply to become 2 over 3 sec squared theta d theta. Then you substitute all of them here. So you'll have 9 over 4 integral of 1 over 1 plus, if this is tan theta, then when they put a square, it becomes tan squared theta times dx, which dx is 2/3 of sec squared theta d theta. Sec squared theta cancels with 1 plus tan squared theta because they are the same, implying that this is going to be 18 over 12, okay? 18 over 12, and by 6, that is 3 over 2 d theta, which is the same as 3 over 2 theta plus c. But a scenario where you have this one equaling to tan theta, it means that theta is the tan inverse of this. So implying that my integral is going to be 3 over 2 tan inverse of 3 out of 2 x plus 3 out of 9 plus a constant. But this is the case of only this, so we have to merge it with the other one. We have to merge it with the other one. It implies that the whole integral of what we are supposed to do, that is 3x plus 4 out of 9x squared plus 6x plus 5 dx is the same as, we bring the first one was ln, it was 1/6 of ln 9x squared plus 9x plus 5, then plus 3 over 9, it was 3 over 9, then integral of this, which we've gotten as this. So times 3 over 2 tan inverse of 3 over 2 x plus 3 over 9, then everything plus a constant of integration, which is the same as, of course, since this one was just a constant, you can add another, now you can bring in a different constant, because when integrated this one only, you got it as a constant. So now you are merging it with the other, you can bring in maybe another constant like k. So this is going to be 1 over 6 ln 9x squared plus 9x plus 5, then plus this one will cancel, by 3, you'll have 3, so you have 3 over 6, which is a half. So we shall have a half, then tan inverse of, okay, tan inverse of 3 over 2x, okay, we can expand to 3 over 2x, then plus, when you multiply this, 9 over 18, which is going to be a half. Of course,
Excuse me.
plus a constant of integration. Yes.
Yes, sir.
Mm.
Here we had it as 6x.
Mm. We had 6x. Oh, yes.
Yeah.
It was 6x. Yeah. A good observation. It was 6x. Good. Mm-hmm. Is it understood, members? Is it clearly understood?
Yes.
Okay. So since it is clearly understood, do you need one more example on this, or I let you do the exercise?
Shall one more?
Mm. Okay, let's do one more. I will be very fast because I have to look at another case. You have the integral of x plus 2 over x squared plus 2x plus 4 dx. One may not easily tell that this one has not got real roots, but you can put it on the calculator and see if you get real answers. If not, split. So of course, shall say that the numerator is equals to a. Then we get the derivative of the what? Of the denominator, then plus b. So the numerator is x plus 2, and is going to be equal to a. Derivative of the denominator, it will be 2x plus 2, then plus b. So x plus 2 is equals to 2ax plus 2a plus b. On comparison, by comparing the coefficients of x here, we shall have 1 this side is going to be equaling to 2a, implying that my a is a half. Comparing the coefficients, this side we have 2, and it's going to be equal to twice a plus b. So a is a half already, b, so b is going to be equal to 1. Having this would imply that my integral of x plus 2 over x squared plus 2x plus 4 dx is going to be equal to, here you can factorize out so that the a is put out, and since it is a half, I will say a half 2x plus 2. A half, because it is a, I've put it out. So it is a half into 2x plus 2, which is this, over the denominator x squared plus twice x plus 4 dx plus integral of the value of b, which is 1 over x squared plus twice x plus a 4 dx. You can factorize out a half there, so it is going to be a half integral of 2x plus 2 out of x squared plus 2x plus 4 dx plus integral of 1 over x squared plus 2x plus 4 dx. This is going to be a half ln y, the derivative of this is this, so ln 2x, no. Then x squared plus 2x plus 4 plus the integral, I may need to work on this, x squared plus 2x plus 4 dx. Then I need to work on I need to complete a square here. Now let me work on that integral separately. So for the integral of 1 over x squared plus 2x plus 4 dx, allow me to say that this is going to be equal to allow me to say that this is going to be equal to, of course, when you're completing a square here, it's going to be x squared plus 2x plus a half coefficient of x. Okay, we shall add a 4. We shall add a 4. Then we are looking for what to put here. A half coefficient of x, then squared. A half times coefficient of x, which is 2, then squared, and that is plus 1. Eh? So that is plus 1 squared, which will keep 1. Okay, it's like plus 1 squared, which is 1, because this is 1. Then here, for equality, we shall subtract a 1. So when you complete a square, it will become x plus 1 squared, then plus 3. So here, that is what we shall take. So we shall have integral of 1 over 3 plus x plus 1 then squared dx. Of course, you cannot work on this integral when this one is not a 1. So we have to factorize out a third. Eh? So it's going to be a third integral of 1 over, here we are left with 1, then x plus 1 squared, but out of 3 dx. So for us to bring in the tan theta aspect, we have to ensure, okay, we have to really ensure that this one here is also square and you don't change the meaning. So you have to put it under root, then we square. So this is going to be a third integral of 1 over 1 plus x plus 1 over root 3, then squared dx. So that way, you can let in your tan theta. You can bring in your tan theta faster. You can bring in your tan theta. Well, at this case, or at this stage, that is when I bring in my tan theta, and I will say that let x plus 1 over root 3 be equaling to tan theta. This is the same as 1 over root 3, or one can say 1 over root 3 x plus 1 equaling to tan theta, implying that when you differentiate this side, it will be 1 over root 3 dx is equals to sec squared theta d theta, meaning that my dx is going to be root 3 sec squared theta d theta, then the whole integral. Of course, if this is the theta, then my theta is tan arc or tan inverse of x plus 1 over root 3. So this one will come to our integral. If I substitute, it will be integral. I have had my third outside, so it is going to be a third 1 over 1 plus tan squared theta, then the x is root 3 sec squared theta d theta. Sec squared theta will cancel with this. Then here you put root 3 over 3 outside, it is going to be root 3 over 3, then integral, okay, of 1 over, okay, we are left with just the theta. So it is going to be root 3 over 3 theta plus a constant of integration. But theta, we have it as tan inverse of x plus 1 over root 3 plus a constant of integration. Then we merge them. So it would imply that the integral of x plus 2 over x squared plus 2x plus 4 dx is equal to, we had a half in x squared plus 2x plus 4, then plus it was the integral of this, and the integral of that is a root 3 over 3 tan inverse of x plus 1 over root 3. Maybe I can say plus constant k, and that is the answer. If you're with me, now if it is clear with your soul, type yes. If it's clear with your soul, type yes. If it's clear with your soul, type yes. Okay. Okay. I love that. Allow me to take you to the case now where we are having the form splitting a numerator for the cases that involve trigonometric functions. And I will use just 30 minutes to do like 2 examples for you, and we call it integration. There you will be free to attack a QB for any number of integration. Now, our case 2, that is why we are finding integrals of fractional trigonometric functions that are expressed in this form. You find a fractional trigonometric function expressed as a cos theta plus b sin theta out of c cos theta plus d sin theta d theta, where a, b, c, d are constants. Here, if you're having a function of this form, we split the numerator. Now here comes a difference, okay? We split the numerator as the numerator is equals to a times derivative of the denominator plus b times the denominator. For that case, on the other one that we had previously, we add the denominator on b. So here you need to have some good ideas of comparison. You should be able to compare and tell that this is this, this is this, this is this. Anyway, for this case still, we are going to look at simpler work. Just on the formula you had previously, add the denominator in brackets of b. Right. So let's enjoy this and how simple it is. How simple it is. How simple it is. Examples. This is very, very, very interesting. I think the most interesting examples. Find one integral of 2 cos x plus 9 sin x over 3 cos x plus sin x dx. Hey, find that. Find that. 2 cos x plus 9 sin x over 3 cos x plus sin x. That is what we are having. Okay? That is what we are having It is very, 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 very super interesting. Now here, apply the logic that you got. We said that if it is in this form, we split as numerator is equals to A times the derivative of the denominator plus B times the denominator. Very interesting. So our numerator is 2 cos x plus 9 sin x. It is going to be equal to A times derivative of the denominator. You need to be knowing how to differentiate cos and sine. Members, when we differentiate cos, we get negative sign. So it is going to be A into negative 3 sine x plus, when we differentiate sine, we get cos x. Then plus B into the denominator. The denominator is 3 cos x plus sine x. That is what we are having. Now, still go ahead and say 2 cos x plus 9 sine x is equal to, multiply so that you correct like terms, negative 3a sine x plus b cos x plus 3b cos x plus b sine x. Well, just say 2 cos x plus 9 sine x. Yes, Emily?
Yeah, you missed out a cos x on the when opening the first bracket.
Negative 3a sine x plus a. It is supposed to be a, right? Good. So when you look at these members, you factorize the ones of sine x and the ones of cos a of cos x. So for sine x, we shall have negative 3a and b. So we shall say negative 3a plus b sine x, then plus those of cos, it is a and 3b. So a plus 3b, then cos x. You equate coefficients of cos and sine either way. So equate coefficients for cos x. This side we have 2. And this side we have a plus 3b. A plus 3b. That is the equation 1. All right. For sine x, when you equate this side, you have 9. And this side you've got negative 3a plus b. Solve simultaneously and get the values of a and b. A will be negative 5/2, and you get your b as 3/2. Solve simultaneously, get these values here. What does it imply? What does it imply? It would mean that your integral of 2 cos x plus 9 sine x over 3 cos x plus sine x dx is going to be equal to a into this, then we shall divide by the denominator, of course. So it will be the integral of a, which I've gotten as negative 5/2, but of negative 3 sine x plus cos x out of the denominator, which is 3 cos x plus sine x dx, plus integral b. B is 3/2, okay? 3/2, then 3 cos x plus sine x over 3 cos x plus sine x dx, of course. So this is going to be equal to negative 5 over 2 integral of negative 3 sine x plus cos x over shall have over 3 cos x plus sine x dx plus, we factorize out 3 over 2 integral of 3 cos x plus sine x over 3 cos x plus sine x dx. These ones will cancel. 3 cos x, the whole of this one will cancel, but this one here is negative 5 over 2. When you differentiate this, you get this. Therefore, ln, okay, ln 3 cos x plus sine x plus 3 over 2. 3 over 2, when you see that this one is the same as this, so you divide them. So integral of 1 dx, so it will be 3x plus a constant of integration. That is what we have, members. As simple as that. Very, 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 very simple. It is very, very, very simple, and very simple as that. Okay? If you're with me, members, type a big yes. If you're with me, type a big yes. I'm not seeing big yes. Isco has typed a big yes. That Isco, members, is a Spaniard. Oliver is also a German. Yeah, John, I'm enjoying this. I'm really enjoying this. This is hyper perfect. This is very, very, very perfect. This is very, very perfect. Now, I really don't see any problem with these numbers. Let me do one more like this, and we call it a day. Let me do one more like this. 2, we're having the integral of cos x. I'm enjoying this. Let me consider cos theta over cos theta minus 2 sine theta d theta. Like that. Never should you mind how it is expressed. Never should you mind how it is expressed, provided you see trigonometric function throughout as a ratio. Split the numerator cos theta is equals to a times the derivative of the denominator, which will be negative sine theta minus 2 cos theta plus b times the denominator cos theta minus 2 sine theta. That is what we have. So everyone should be able to tell how this step comes about. If you understand what I've done here, you can put a thumb or you can type yes if you know, because I know one may not know. What confuses students is the derivative of a cos and a sine. They confuse them with the ones of integration. You need to first note the difference between the two. So, very well. Esther is like yes power 100. So now this is going to be cos theta. You're going to expand so that you factorize out. So our cos theta is going to be negative a sine theta minus 2a cos theta plus b cos theta minus twice b sin theta. Someone can call it sin theta, but the word is theta. So a theta. So now here you can factor out cos theta is equals to, we factor out those of sine separately. So we shall have negative a minus 2b sin theta. Then for cos, we shall have negative twice a plus b cos theta. So you can compare the coefficients, and if you compare beginning with the cos theta, this side you have 1, the coefficient is 1, and this side you have negative twice a plus b. For sin theta, this side we don't have any sign, so 0 is equals to negative a minus twice b. Solving these equations simultaneously, I mean these two, solving them simultaneously will give you the value of a. We give you the value of a as negative 2 in 5 and b as negative as 1 in 5. Now it would imply that your integral of cos theta over cos theta minus 2 sin theta d theta is going to be equal to the integral. We first put a, which is negative 2 over 5, then negative sin theta minus 2 cos theta out of the denominator, which is cos theta minus 2 sin theta d theta, plus the integral of b, which is 1/5 of cos theta minus 2 sin theta over the denominator cos theta minus 2 sin theta. Realizing that when you differentiate this, of course, after putting out negative twice integral of negative sin theta minus 2 cos theta, of course, this is also d theta, over cos theta minus 2 sin theta d theta plus 1/5 integral of cos theta minus 2 sin theta over cos theta minus 2 sin theta, everything d theta. So it's going to be negative 2/5. When you differentiate this, you get that. So in cos theta minus 2 sin theta plus 1/5, these ones cancel. So here you have d theta. When you integrate d theta, you get theta plus a constant of integration. If you're with me, type yes. If you're with me, type yes. If you're with me, type yes. And as you do that, I'm putting an exercise for all of us. Exercise, evaluate A, the integral from pi over 6 to pi over 2, these are limits, cos x minus sin x over 2 sin x plus 3 cos x dx. B, be integral of 0 pi over 2 sine x out of 3 sine x plus 4 cos x dx. Then you can also find the integral of sine x plus 2 cos x over 4 cos x plus 3 sin x dx. And that one brings us to the end of the topic. Our next topic is going to be complex numbers. I intend to move it along with this topic of differential equations, because the moment you handle differential equations, at the moment you handle differentiation and integration, then differential equations should merge in. That is the very tricky part. Every year that number appears as number 16 most of the times, the number of differentials. So you are sure that you have numbers to do in cases. You are sure that you have numbers to do. I wish you all the best, members. I really wish you all the best. The mighty God bless you till we meet again. I love you all. Thank you, Rachel, Oliver, John, Mercy, everyone. Thank you. Isco. So till we meet again, stay blessed.